So in this video, we're going to be finding the component form of a vector. So the example that we have here says find the component form of a vector that represents the velocity of an airplane descending at a speed of 100 miles per hour at an angle of 30 degrees below the horizontal. So if we look at this, what's important to note is velocity is really just going to be our magnitude. In this case, that's going to be our speed of 100 miles per hour. And then it says that it's going to be at an angle of 30 degrees below the horizontal because we're descending, right? So we've got our 30 degrees below the horizontal, and we know that the horizontal is 180 degrees, right? Like if we were to, right here, look at this. This is 180 degrees. And so we want to go 30 degrees past that. So we're going to need to take that 180 degrees and add that with this extra 30 degrees, right? So when we add that, we're getting the 210 degrees, which is what they have right here. Okay, so that is our theta. So we have our vector v, and we can see that the magnitude of v times the cosine theta of I plus the magnitude of v times the sine of theta times j will give us our vector. So we can plug in the things that we know. So we have 100 times the cosine of 210 times I plus 100 times the sine of 210 times j, and we're almost done. So what we want to do now is we want to evaluate the cosine of 210 and the sine of 210, and we can do this by looking at our unit circle. So if we look at our unit circle and look at the cosine of 210, we're going to see that gives us a value of negative radical 3 over 2, and that the sine of 210 is a negative 1/2. So now we can go ahead and plug that in, which gives us 100 times negative radical 3 over 2 times I, plus 100 times negative 1/2 times j. And by simplifying, we get a negative 50 times radical 3 times I, or not plus because it's a negative there, minus 50j, which we can then write in component form as follows: negative 50 radical 3, comma, negative 50. Now we want to check our answer and make sure that we're good. So we want to make sure that we have a magnitude of 100. And so we'll just calculate our magnitude, which means that we're going to go ahead and plug in our components squared. So negative 50 radical 3 quantity squared plus negative 50 quantity squared. And when we plug that into a calculator, we see that we get an answer of 100, which is the magnitude that we were given for initial problem. And so our problem checks out and we're finished. And so here is our component form of our vector.